Okay, this is going to be a video showing how you can use shell scripting to automate a CFD parameter sweep. Um, so to give you a little background really quick about what's going on here, so I have this C++ program written with the palabos framework, which is a Lattice Boltzmann software program. And so what I'm doing is simulating this flow through packed spheres. So this is essentially what my solutions look like for a body-centered cubic lattice. And so you can see, like, for instance, in this region right here, this is where portion of a sphere is, and so the velocity is 0 there and high in between the spheres. And so looking specifically at, a cut plane, you can see that the velocity goes to 0 at the sphere surface and is high further away from that. And the boundaries are periodic. So this boundary is adjacent to this. And there's pressure boundary conditions on the inlet and the outlet driving the flow. And so this is good, and there's no reason to assume that this program is not working correctly. It's capturing the boundaries of the porous medium pretty well. But what I wanted to do is, like, as you can see, this stereolithograph of my porous medium is pretty coarse. So I want to be able to both improve the resolution of the spheres and also to be able to control how far the center of the spheres are from one another. And so to be able to do that, I need to be able to control my program in an automated way. So to show you really quick the program surface that I have, so this is essentially the way I control this program. And so I give these arguments are read by the C++ program, and they tell it the dimensions of the cube and the radius of the spheres and which type of lattice. So this can be body-centered cubic or simple cubic. And so what I want to do is I want to maintain the ability to use this parameters file. And so that at any time I can always look at an individual solution and just modify this and get a new solution. So I want to essentially write a script that will control this and be able to execute the program. So to show you, this is essentially the outline of what this program, or this script rather, will do. It's going to write this file, generate a new lattice, execute the C++ program, and extract the relevant parameters that I'm looking for. And so to show you really quick, like, what this would look like if you're doing it by hand, say, okay, let's say I've finished this lattice size, and now I want to do radius equals 14. So I'd change that manually, generate a new lattice, and then run the program. And once it converges, I want to say, okay, I want to extract this permeability line, so I'm going to copy this. And so what I'm trying to show you is that this is both tedious and error prone, because you're getting one value out here, and there's other values that I want to have, and I want to store the simulations. And so this is all to emphasize sort of the value of doing something like this, because what I'm doing is very simple. I'm just changing one value and then executing programs that don't require any other inputs. So so real quickly, I'll go over some of the stuff in here. So this is a shell script, and sometimes the syntax can be a little weird looking and kind of ugly, but one piece of advice rather that I have is that if you are interested in shell scripting, and so I do this for a lot of different programs, but I just keep like text files with my notes about how to use these programs and languages. So, like for instance, I have this bash one, which, bash is just one type of shell. I try to keep things shell compliant so they can run on any shell, not just bash. So like POSIX compliance. But I have just basic functions on here and how to use them, and so I have like an individual one for grep and awk, just with different things, and sed, because those are kind of the most common, and they don't all have exactly unified syntax, so it can be nice to have just a quick reference to look at. So getting into this now, again, the first thing we want to do is rewrite the parameters file. So I've written this function, which because this is such a small file, and I think sed, the program sed, which stands for stream edit, is really probably the best way to do this. But because this file is so short, I'm just using echo, which is like print in, for instance, Python. It just prints its argument to the terminal. And so by directing the output, that just executes, instead of printing on the terminal, it will echo that command to whatever this file is. So like for instance, if you just did like this, so now I've directed this into temp, and so now temp has hello world in it. So so that's essentially what's going on here. I'm echoing these different lines onto a file. And so real quickly, the function syntax for shell scripting is the function name followed by closed parentheses, and then the body of the function goes between curly brackets. And so it can be multiple lines. You have to end the lines with a semicolon. And the other thing is that the arguments inside the body of the function are denoted by their number. So like for instance, $1 is the first argument to that function. So a call to this function would look like, instead of, in Python and C and C++, you typically surround the arguments in parentheses, but in shell scripting, you just provide the arguments with spaces. So like for instance, if I wanted this to be temp.txt, and then I want my nx value to be 35, and then my radius to be 8, and then that would be like, for instance, the example syntax of how to call this function. So again, the first argument that is getting passed to this is params.xml, because that's the name of the file that I want to write. And so it's just being provided the dimensions, which is the length of the sides of the cube and the radius of the spheres. So the next function that I have is this test_c. And so this is maybe a little bit unimportant, but I mean, it's important for what I'm doing, but you may not have something like this. But what I wrote this for is to test if the spheres are touching or overlapping, so that when I'm sweeping through these different lattice sizes, once the spheres are overlapping, I can tell it to quit. And so that's the point where I no longer want to continue. So for instance, with the simple cubic, once the lattice is over half that, this will return false. And there's another line in here that needs this to be true to continue. So that's what this is for. And then extract is just using, it's just kind of this shorthand I wrote for, I kept using this syntax using grep to get values out of, so like, let me just show you really quick, essentially how I'm wanting to do this. So like, this is just directing the output into temp.txt. So if I want to get this value from this file, you can just do so you have this, and so that extracts this line, but I want just this number, and so awk can extract these different values, and nf is the argument to get the last value. Like, these are separated by spaces, and so that will return this last value. So this is just a little shorthand that I wrote that takes the first argument is the string to match. The second argument is the file path, and then this just extracts the last line. So that's essentially, this is like the template of how that works. So you'll see that I've used that for a couple different things that I want to extract. And so with awk, I have my notes about that in my little notes thing, but you can give it column numbers is another way to use awk. NF just gets the last one, but you can do 1 or so, like, for instance, with this one, 3 would be another valid argument to get that value, but there were some some of these other parameters didn't have exactly 3, so I was just getting exactly the last value. So now getting into the body of the script, most of this is pretty basic stuff. I'll try to explain it. So the first thing is just the parameters file. So this is going to be an argument to write params, which is the title of this file. And so again, like the my generate lattice file reads this, and so also the C++ program does. So that's necessary that my parameters file is named params.xml. So we're going to have an output directory where we'll store all of the different simulations. So we're going to have essentially my higher order data, which I'm calling meta, even though it's not, I guess, strictly speaking metadata. It's just the data from the perspective of the parameter sweep. And so we're going to create that directory and a batch data.csv file. And so this this syntax right here is like a conditional. And so it's testing if this file exists, and if that's true, deletes it. So this double ampersand is a way that you can have kind of a compact conditional syntax in shell scripting. So it essentially is just saying that if this returns, execute the second half. If it doesn't, then don't do this, because if that file doesn't exist, then there's nothing to remove. So touch is a shell command that just creates a file. So this deletes that file, and then touch creates the new one. And then this just writes the header for the file. So again, the double arrows are for appending a file. So this is just appending these 4 lines to that file. And so now we get down to the actual looping. So actually the sweeping part of this. And so we want to change nx. And so although this is nx, ny, and z, I'm just there, since it's a cube, and these are all going to be the same. So I'm just sweeping nx here. And so you can see back up at the right params, they all are taking the same argument. So this is just for formatting to let you know, okay, it started a new nx value. And so first thing is to create a new directory for the output for a specific cube length. So all of the, if I have a cube length of 31, all the different radii will be inside that directory. And so the next thing is to start with a radius of 2. And so that's just to give some kind of stability. If the if the radius is too small, the program is not stable. So, and you'll see that even with radius of 2, it's still is a little bit unstable. But that's one thing I'm wanting to see is like where's the threshold where the solution will become stable. And so next it calls write params. And so it takes its argument is params, which is params.xml, the new nx value, and the radius. And so we're starting with the radius of 2. And so I have this initial write params here just so that this while loop can start. And so again, what I had said is I have that testing file, which just tests to see if the spheres are overlapping. And so if this is true, that means the spheres are not overlapping. And so this is the body of this while loop. And so it's saying, okay, and so this, as you can see with an echo command that isn't directed into another output, this will just print to the terminal. So it's going to tell me the cube edge length and the radius. And then it's going to write params. So again, I executed that here just so that this will start correctly, but once it's started, the write params will always happen right here. And so then it does this test C again, and if it executes correctly, it will generate a new lattice. And it directs the output of that lattice into lattice.dat. So this is some of the information that I want to be able to extract later, which it's basically the volume fraction, or how much of the cube is filled with the spheres, and the reference permeabilities. So these are values that I want to be able to store, and so I'm just writing them to this lattice.dat file. And so this actually executes the C++. So this is a message passing program, so it's using MPI execute on 4 processors on my home computer, and it directs that output to palabos out.dat, because that is essentially what this this temp file, that's what this file will look like. And so I want to be able to extract this permeability from these files, and also how many iterations it took. And so this command mv is just move, and so the palabos program is always writing to this temp directory. So there's, in this directory, it's got the stereolithograph, a VTI, and the solution. And so that's what these files are. And this is, again, this lattice right here is 60 cubed. So this one that it's generated is much lower resolution than that. But so what it does, though, is after the program is executed, this directory is populated with these files. And so it just moves, and move is also like rename. So it's moving this directory over to batch output with the edge defined correctly and of that radius size. So this is a single instance. And so next, I want to extract these values. And so again, with that syntax I had showed you earlier, with this grepping values and just extracting the last value, here's where I'm able to use that syntax I showed you, where I want to extract the permeability. I'm telling it the path, and it will return that number to this variable perm, or permeability. Similarly, number of iterations, reference permeability, and volume fraction. And so then I'm echoing or printing these values and directing that output to my meta data file. So for each simulation, it's just taking these essential values and printing them to a CSV file. And since I moved this temp directory, I need to make a new one. So mkdir is make directory. And so it creates the new temp directory and increments the radius by 1. So while this, may seem a little bit tedious. I think it pales in comparison to the tedium of actually doing this by hand, and so this just automates this whole task. And again, I kind of put this together sort of hackily. You can use sed instead of this. If you didn't want to write this write your params file like this, you can use sed, which just to show you really quick how it works. So you can have a string, and sed you can use to replace. So you can replace the instances that match. So you can see this is replacing howdy with hola. So hello, hi, howdy, hello. And so this is another, this is like a really powerful, really nice syntax for controlling, you can see how you could, instead of rewriting the whole file each time, you could just rewrite this line or just this value. But again, since this parameters file is so short, I just decided to make a little function that writes the whole thing. So now I'll show you how this works. So, or what it looks like when it's working, I guess. So again, it's echoing this line, showing you it started a new NX. So it's got, now it's echoing NX and my radius, and so it's sweeping forward. And so these are true, meaning that the spheres are not overlapping at this point. And so if you wanted to look at the, so a nice thing about this also is that, this is, all these commands in here are exactly equivalent as if you had just typed them into a terminal. So there's not, the concept of this being compiled or isolated away from its execution. So these things can still be modified. And so, like, for instance, if I modify this generate lattice, if I'm like, oh, I want to see what these lattices that it's producing look like, you can still change it right here, and it will print, and it'll start to show you these lattices. And so, normally you obviously wouldn't want that to happen, because with matplotlib, for instance, the program hangs whenever it prints, or whenever it shows a plot. So the program won't proceed while it's showing me this. But if you were interested in seeing it, you can. That's what I was trying to demonstrate, is that you can see this output live. And so this is like, for instance, where now the spheres are overlapping, and so it'll return a false, and that means that it will now switch over to NX equals 31. And so let me suppress this output really quick. And so another thing really quick, so I guess to sort of emphasize another reason why it's nice to keep notes about shell scripting is, like, for instance, this is how I wanted to describe this for loop. And so there's with shell scripting, it's pretty flexible in terms of for loops, and there's a bunch of different types of syntax that you can use for it. And so, like, I have in my notes for this just a fold just about different for loop syntaxes that you can use. And so it supports like basic, I would call this like the C or C++ style for loop declaration. But it also has more like the Python type syntax also is supported. But this one that I wanted was the, incrementing by a certain sequence. So this keyword seek is just saying that iterate from 1 to 20 by incrementing by 2. And so here I'm incrementing from NX equals 21 to NX equals 31. And so since I'm going by 10, it's just going to take 2 values. And so, you could also, instead of, if you wanted to have a more coarse sweep of the radius, you could sweep this by 2 and incrementing it, by 2 from here. But this is just, how I wanted to write this. And again, it's kind of, you can kind of hack something like this together. And so you could, I guess, theoretically do something like this with Python without a huge level of effort. But the nice thing about shell syntax, like I said, is that it has all of the native commands that are in your terminal. So like a lot of the stuff that is going on here is just like file manipulation and extracting, a single line, where in Python you can use regular expressions in Python and match strings, but you're gonna have to use file IO stuff to to read all the files. And grep, this syntax using grep and awk is pretty nice and compact. And so another thing I wanted to point out about this, not just that it's kind of an interesting little thing to do, but that that particularly makes your life way easier. But that you can also deploy something like this. So, like for instance, I'm actually running this on a server right now, and so while I have only 4 processors on my home computer, I have access to many more on a cluster. And so this syntax, if you write shell compliant syntax right here, then you can literally port it directly into a shell script on for instance, a cluster. So this PBS script is what is used to essentially control the execution on this server. So as you can see here, I've literally got the exact same syntax, and I can run this parameter sweep, and instead I can just use, your resources can be different right here. So controlling the parallel execution of your program can be executed with different number of processors. And so at a certain point, the way I have this set up, creating these lattices will become very expensive for Python because it's not extremely well suited for these like 3-dimensional arrays. But this is just kind of showing you that you can use this syntax. It's I guess what I'm trying to show is that it's very portable syntax, especially if you stick to POSIX compliance. And so let's see, I think that's about everything. Yeah, I think that's about everything I wanted to go over, so have fun. So just as a quick little thing to add on here, I just wanted to show you really quick like what the output looks like from that sweep that I did. So we were sweeping from 21, and so we have the radius is this second column, and then we have the volume fraction, and so I have this little, I guess, header showing what all the columns are and out to number of iterations on the last one. So this is the the format where we can now index the data by the dimensions of the cube and the radius.